Thank you for coming, everyone. My name is Takeshi. I'm one of the maintainer of Envoy AI Gateway project, as well as Envoy Proxy 2. And then I'm joined by Jan from Google.
Hi everyone, I'm Jan. I'm the senior maintainer, software engineer at Google.
So today's talk is about Envoy AI Gateway project, as the title suggests. So the thing is that project itself is very new. So I'm going to start with some overview. What is it in the first place, and what kind of problem are we trying to solve? And then I'm going to explain like high-level architecture. Then we're going to do the deep dive on the core features, how it's implemented in the first place. So let's start with what is it? Envoy AI Gateway project is sub-project of Envoy Proxy. I don't know if there's any official definition of sub-project, but it is a separate project under Envoy Proxy organization, just like Envoy Gateway. And we are using Envoy Proxy and Envoy Gateway as a building blocks to solve some GenAI specific challenges. So that's the overview of what Envoy AI Gateway is. And then so there's a couple of the like notable examples of problems that we are trying to solve. So they're not like completely new to AI space, but fairly like certainly they're common in AI, LLM, traffic handling. So one of the notable example is that usage-based rate limiting, unlike static traditional rate limiting, we need to do some rate limit based on some computational cost. So that is, I'm going to do some deep dive on that one later. And next one, high inference cost. So you might want to do some clever load balancing to use GPU wisely instead of some traditional round robin or traditional load balancing mechanism. And then on the right-hand side, you will see variable long latencies. So if you imagine you are using ChatGPT, type in, say hi, then response is very fast. But on the other hand, when you're uploading documentation, say, summarize this one, give me some summary of this documentation, then you're going to expect some few seconds or maybe minutes of latencies. So the latency characteristic is really like context dependent, like depending on the request body, the latency is very like unique. So that is I would say this is not the like completely new challenge, but this is certainly a characteristic of AI requests. And then on the bottom, you'll see intelligent load balancing. I think this one is going to be explained by Yang later. Basically, the traditional load balancing is not working quite well for certain use cases. And then lastly, on the left-hand side, managing multiple GenAI providers. The thing is that at the end of the day, all AI models are the same, like generating text. It's a simplified explanation, but that's true from network proxy's point of view. So from users' perspective, being able to access different models on different providers, that is what we want to achieve in the Gateway API space. So these are the challenges we are trying to solve in this project. And then the project history is that it's been almost 1 year old. It started as a collaboration between Bloomberg and Ted Late, and then the project announcement was last year's KubeCon NA, and then we've released some few versions since then. And then we have, like last week, we've released a new version with some MCP Anthropic supports. And then that's the summary of what we have done so far. So it's 1 year old. Then I'm going to do some like deep dive on the like implementation details. So as I explained, we are using Envoy Gateway as a like core infra layer. So Envoy Gateway is basically the Gateway API implementation. So Envoy Gateway is managing Envoy Proxy itself. So we are not managing Envoy Proxy by ourselves. What are we doing is that we are talking to Gateway API, Envoy Gateway to fine-tune XDS configuration to achieve some AI-specific functionalities in addition to inserting extraproc container to Envoy proxy part to achieve to do some AI-specific logic on the data plane path. So this is the like general overview of how it works. And basically, we have two controllers and one control plane, and we are talking to that control plane to fine-tune XDS configuration. So this is a high-level architecture. And then, so we have few core features, but we cannot explain everything. So I chose three out of them. One is token-based global rate limit, and I'm going to explain how it works under the hood at the Envoy's configuration level. And then I'm going to explain cross-provider model failover and how it works and why is it necessary. And then I'm going to pass over to Jan later on the intelligent load balancing stuff for local self-hosted models. So I'm going to start with the token-based global rate limit. So if you think about it, traditional rate limiting is very static. So like when your request comes in, you decrement the counter. Then when the budget is running out, you're gonna reject all the requests from that point. So basically, we associate the cost as a 1, so static request time norm. But on the other hand, rate limiting in GenAI LLM is that there is a notion called token rate limiting, token usage. What it means is that basically it explains how much computation was needed to generate this specific response. So in other words, in order to do rate limit based on that computational cost, we have to implement some sort of request response context-aware rate limiting. So that's the challenge we had to solve. So here's an example. This is the Anthropic messages endpoint. When you say hi, then AI respond to me nicely. Hi, how can I help you today? So as you can see in the response body, we have usage information. Input tokens are 9. Output tokens are 16. So I would say it's very lightweight request response pair. But when you slightly change the request body, like say hi 100 times, then input token increases, output tokens like 10 times larger than the original one. So this is a very simple example of why token usage-based rate limiting is important to do proper rate limit management. So how are we implementing in the Envoy AI Gateway project? The thing is, we have new API. I have implemented this in Envoy upstream, which is called apply on stream down flag, which is a Boolean. When it is enabled, Envoy will talk to rate limit service on the stream closure. But in addition to this flag, we are using hit-sudden API, which is not, of course, not new one. But you can specify dynamic metadata to specify how much do you want to reduce from the counter. So in our project, we are using xproc, extract the token usage information from response body, then setting it as a dynamic metadata. And then Envoy will reduce that extracted cost from rate limit budget by talking to rate limit service. So this is how we implementing token-based global rate limit. Let me walk you through with the request flow diagram. When you're using OpenAI SDK, you're talking to Envoy. Then Envoy will talk to rate limit service just like any other traditional use case. And then if the request is allowed, then it will reach upstream. Then on the response path, Envoy proxy will talk to xproc, and the xproc will extract that token usage information, then setting it as a dynamic metadata. And then lastly, on the stream closure, Envoy will talk to rate limit service again to reduce the extracted cost from the rate limit budget. So this is how token-based rate limit is implemented in Envoy AI Gateway project. And the next one, cross-provider model failover use case. So why this is necessary? So one of the examples is that on AWS Bedrock, you have 2 tiers for the same models in a different endpoint, provision throughput and on-demand throughput. Of course, the former is much cheaper than the latter. So you might want to fall back when provision throughput is not available to on-demand throughput. So that is one example. The other example is that same models can be hosted on the multiple providers, like Anthropic are hosted on the GCP as well as AWS Bedrock too. In addition, maybe you might want to serve DeepSeek on your local GPU cluster, but you might want to fall back to cloud API provider like DeepSeek cloud models. So these are the examples, but why they're like different from traditional failover use cases? So the challenge is that API schema might be different. So AWS Bedrock has a API called Converse, which is equivalent to chat completions API in OpenAI, but they have completely different API formats. So you have to do the request body conversion on the retry path. The other thing is that authentication authorization might be different. Anthropic has a X API key header. On the other hand, Azure Open AI has API key header without X hyphen prefix. And also, AWS Bedrock requires request signing on the request body. So we have to do that logic in the retry cycle, retry loop. So how are we implementing is that we do all these logic in the XProc upstream filter, because upstream filters are called per retry. So this is the very simplified distilled version of Envoy cluster configuration we are using in Envoy AI Gateway project. So we have two, like depending on the configuration, but in this example, we have two priorities. One is for Anthropic, one is for OpenAI. And then as you see, we have metadata for like backend name Anthropic, backend name OpenAI. So we are using this metadata to switch the logic to like authentication, authorization, translation. So we are switching the logic depending on that metadata on that retry path. So the thing is, this is not the only possible implementation. Just we are using the Envoy Gateway's implementation on top of this one. Yeah, that is pretty much it. So I'm going to pass over to Jan on the self-hosted models.
Thank you, Takeshi. So up till now, we looked at how you can serve external external models through Envoy AI Gateway. However, it also supports serving the self-hosted models. So you can have a single abstraction layer that goes either to external or self-hosted models, or provide failover the same way as you're doing between the external models. The serving of inference workloads presents its challenges for Envoy. I made a table with some of the differences. This is, of course, generalization. You can put some traditional GTP requests into the right side. There can be expensive non-inference workloads, like maybe querying something expensive, like running expensive query in a database. But there are some key differences that that are definitely there, and definitely make a difference in how Envoy has to, or Envoy and AI Gateway together with all of its ambient infrastructure has to work. So one of the big differences, that the difference sounds small, but it actually makes a big impact, is that traditional requests, the service selection is done on some properties that are coming from typically from a GTP headers, maybe from TLS properties, but it's the properties that are available at the beginning of the request. For the inference workloads, they commonly come from the body, from the JSON payload of the body. And given just the nature of JSON, it means that you actually have to get the whole body before you can figure out where this request has to go. So Takeshi already mentioned about the cost. So this is a very different model, right? The costs are much higher, orders of magnitude. Like at Google, we on average expect, 3 orders of magnitude difference in costs. And it's also from request to request, the cost is very different. and that actually impacts, the topic that I'm talking about, the load balancing. In traditional workloads, you will have some imbalance. That's unavoidable, and it comes from the fact that there is small differences in cost of how of request processing that leads to load imbalance. And normally you deal with that by slightly over provisioning your services, and slightly over provisioning LLM models can cost you a lot. So that's not an option here. And also there are other interesting aspect is that in inference requests, you may have to take some properties of the request from the body, and actually some endpoints might be more suitable for handling that request than others. That may be, for example, if you determine that there is a warm cache on one of the nodes that might work faster, or especially in disaggregated serving. But that's actually a subject that I wanted to touch on, but I don't think I will be able to on today. And sort of another big difference is how the buffering is done. In traditional workloads, you typically try to handle as much traffic as you can with as little memory as possible. But in the inference workloads, that's normally not, it's not going to work, just because you need that body, the request body, to know what to do. So going back to the load balancing and the load imbalance, here's one of the examples where, let's say, a traditional load balancing algorithm like round robin might not work, because the requests have different costs. You may have a different queue length on different endpoints. If you're just simply doing round robin, you may end up placing requests on the hosts that have a longer than normal queue and incur more latency. So to address some of these problems, we are using the inference extensions. So that's a Kubernetes gateway API inference extensions, and the name changed multiple times. I know it's a mouthful. So it's a CRD that allows you to define the model pools, the objectives on how these model pools have to be selected based on request properties, and also defines a protocol for implementing load balancing externally from Envoy, and that's the big difference that I'm going to talk about this. There is already a reference implementation for this external load balancer. I should have a link later on. And so the idea is that I think there are right now 2 implementations that are using that. I'm actually not sure if there's, maybe there's more by now. So Envoy AI Gateway is one of those. So configuration is a little bit more involved. And here on the left side, I actually didn't include all of that. On the left side is the definition of the inference pool, and on AI Gateway side, you reference the inference pool in the backends ref. So that's how you hook up Envoy AI Gateway to the inference pool. The important piece here on the left side at the bottom is the inference pool also specifies that external endpoint picker, which is I didn't include it, it's a separate deployment. This is all available in the examples in the Envoy AI Gateway, so if you have to put the system together, you can actually do that. So this is a little bit of an explanation of how request flows when the endpoint picker is present. So the request comes to Envoy, and it goes, you already heard multiple times, that the xproc service, that's the endpoint picker extension, and Envoy sends all of the request attributes to that extension. Sometimes it can send the whole body, and the job of the endpoint picker extension is to find the most suitable host. So it in the background, it constantly scrapes the Prometheus metrics. It looks at, what's the queue depth on all of on the different hosts, CPU cache utilization. It can do, I believe these versions can actually do the prefix, compute prefixes, and so do cache selection, host selection based on prefixes. And at the end of its computation, it provides Envoy with the endpoint that it thinks would be best for serving that workload. And Envoy takes that endpoint, it bypasses any of the built-in, it can fall back to a built-in load balancing algorithm if endpoint picker fails. But normally, if it's present and it worked, if provide a endpoint, it will pick that host and send the request to that host. So the reason for why we needed the external endpoint picker is that, first of all, it's a global state. All right. So if you have a fleet of Envoys, it would be difficult to. You may still end up with imbalances if each Envoy maintains its own state, because if they all decide to use the endpoint with the lowest queue, then the shortest queue, then they will very quickly overwhelm just that one host. So that's why you need to separate this state into a separate service where you can maintain a global state. And the other reason is that we wanted to iterate very fast, and Xproc provides probably the fastest way to iterate on Envoy features. So the combination of these things kind of ended up having us with the Xproc server. How that's going to evolve in the future, I don't exactly know. There are multiple attempts to try to maybe bring this into Envoy, make it native, so you don't need to keep a separate service. So we're still working on simplifying that piece. So these are some results that I put in from the benchmarking for Cloud Next. So you can see that for some metrics, you can get a significant benefit from running an external endpoint picker.
Yep. Let me wrap up the talk. So project state is that we have maintainers from 4 companies. Now we have 60 plus contributors with high growth. What I meant by that is that I think 40 out of 60 are coming from last 2 or 3 months or so. So we have high growth, and we are looking to have a ZA next year. But we have so many things to do. But let's see. Yep, that is pretty much it. Thank you for coming. We have a Envoy AI Gateway Slack channel, and of course we have repository. So yeah, thank you everyone. Any questions? Oh,
does this work? All right,
it does
great.
work, yes.
All right. So I have 2 questions. Also, great talk. So how does the endpoint picker know the endpoints that the particular Envoy proxy has?
Right. So maybe I should have included a configuration for endpoint picker. You have to specify the labels for the service for an inference gateway. So the endpoint picker has its own separate configuration and deployment, and you just give a labels, and we'll take the endpoints from the endpoint slice in the Kubernetes. It gets its own. It continuously updates its own set of endpoints.
Sure, but I guess if the Envoy has, say, subsetting applied or something, right? So it might not know all the different hosts. Does the endpoint picker also know through that out-of-band channel, kind of, hey, this Envoy has these endpoints?
You can do that. It's not, that configuration is not available today in the AI Gateway, but it's possible for Envoy to also tell the endpoint picker that I only have a subset. Pick from that subset. There's a separate extension that's needed to be present in the filter chain, but that's for next version.
Great. And then a question about the rate limiting. So I guess you don't really know how many output tokens you will need beforehand, right? So I guess how do you I guess you can get a really expensive query and then I don't know, just be
sorry, repeat again.
forked.
Sorry, could you repeat again?
Sure, yeah. I guess you don't know the output token costs until everything's fully computed, and then then you can,
That's the limitation. So you need you cannot have 100% complete rate limiting on that, because by nature we cannot know until the response is back. Yeah.
Hi.
Hi.
I'm gonna pick from this last question regarding the global rate limiting, because like you said, it's impossible for you to know the total usage, right? So in the case whereby you've limited it, is it gonna fail over the model, or that particular request is not completed?
So you mean how to the request attribute?
Yeah, because
So basically you can use the Envoy's rate limit API, where you can configure whatever configuration, including model names, which is included as a header name, so that you can configure whatever you want, like condition.
So if you limit it based on the token, does it fail over if that particular usage is exceeded?
That is a work in progress. It's not working yet.
Okay.
Yeah.
Okay. All right. Thank you.
Hi.
Hey.
So my question is more related to the roadmap. Do you feel that Envoy is well positioned to be a proxy in this new AI world? And I'm asking this because we are seeing some traditional vendors and communities of Envoy stepping away and building their own custom data planes. Looking at the hard work that was done to support MCP in Envoy AI Gateway, you had to split up the proxy into, inject a Golang proxy in the middle. These are difficult things, the challenges that you were discussing today. So I guess, is Envoy well positioned to survive as a relevant proxy in this AI world? And I mean, is there significant willingness from contributors of the proxy itself to adjust it to all of these new use cases that are so rapidly evolving? And there's a new spec of all these protocols every day. It's so hard to keep up. What's your take on that?
So I'm going to speak from Envoy AI Gateway's perspective. So MCP is, for example, it's not fully implemented in Envoy proxy side, but in the long run, I would like to have core Envoy implementation. I'm going to just use that one in Envoy AI Gateway project in the long run. Yeah. And then, do you have any additional?
Is Envoy well positioned right now? I'd say probably not. There are gaps, and we are actively working on closing the gaps. I think our goal is to make sure that Envoy is relevant and it can support the new protocols, MCP, A2A, whatever else, the next iteration or evolution of these protocols out of the box, so that we don't need all of this additional XProc servers and crazy machinery under the hood. Simplify all of that. So yes, we are actively working. There are engineers in this room, so come over. So we take contributions to help with this. But I fully expect that it will support all of the relevant protocols for GenAI probably within a quarter.
Okay. Yeah, the challenges are big, so I'm
Yes.
happy to hear that
Let's
there's a willingness
it's also a
to solve
moving
them.
target. The challenge is also it's a moving target. The spec
Exactly.
can change, in a matter of months. You can start with something and in a couple of months realize, oh, actually, I don't need any of that because the spec has changed.
Yeah. Thank you.
See.
That was a great talk. Thank you. So you mentioned that some of your routing information will be included in the body of the requests. That seems not super efficient. Do you have any power to inform the client APIs that they'll be calling and say, actually, well, we want to do a better job of load balancing or whatever. Could you do something different in this way, or?
We have some power. We don't have an absolute power in this case because the community is much bigger, and I think a lot of it has already been implemented and working. So we have to deal with what's already, what is already an acceptable practice today, acceptable protocols today. We're working with individual vendors to try to simplify the schema. So we will see how it goes. But I expect from my perspective that it's probably going to be the reality for the, for the foreseeable future. And then maybe eventually as the ecosystem stabilizes, these type of optimizations will be implemented, that we don't need to actually parse the whole JSON body, which I think will be even a bigger problem for multimodal inference requests that can be very large. For text, it's less of a problem, but for multimodal, it will become definitely an issue, and we'll have to adjust the protocol for that.
Thank you.
One question, how friendly do you see Envoy Gateway and Envoy AI Gateway in an environment where Istio service mesh is running and you want to basically regulate calls to external LLM providers?
I think that question boils down to how easy to use Envoy Gateway in an Istio environment. Sorry, I am not expert in that aspect, but some people are using an ambient mesh as a waypoint proxy for Envoy Gateway. I think that's the only thing I can think of. Yeah.
Okay.
Yeah.
Thank you.
Hi, Adrian.
Hello, I'm a contributor. So I wanted to actually comment and echo back to you guys on a previous comment. So this is the whole is Envoy appropriate or not? And I think another question would be, why is anything appropriate? Right? Because if you're putting something at the edge of your network, do you want to just have it written yesterday? So we should not be so beating on ourselves about technology, because it takes some time to work out. The other thing I would say is what are the key issues about GenAI? Everyone says instability, right? So you have stable software with release cycles. How do you change it quickly? And one thing that's interesting about Envoy AI's architecture is these external processes, or maybe in the future, dynamic modules, which are modularizing those drifty things. But the main key thing that's kind of missing for MCP, because I was also involved in that a little bit, is that it's really that it's not just Envoy Gateway, but there are very few gateways that actually work at the JSON RPC abstraction. So if you have any protocols built on JSON RPC, and it's not like a core protocol, then you're going to struggle not just with MCP, but also there's new agent editor specification, ACP, which is used to allow agents like Goose or Continue or Claude or whatever to access front ends like IntelliJ or VS Code or what have you. And those also work at JSON RPC. So I think the main technical trend to follow in any of these things is JSON RPC support in any product. And then where does that go? Does that push into the core tech, or does that stay nimble? Then you have the weird protocols dancing on top of it, and that code needs to be able to release quickly. So I do think that actually the model of having gateways as separate code base makes total sense for AI, because these top level things change really quickly, but the core JSON RPC 2.0, they're using that, right? And they're using HTTP, and they're using, of course, some streamable dialects, but those are some things. Did I make any mistakes? Okay. And then also the routing thing. I can't resist that.
Is that question?
No, these are comments.
All right,
Community,
I'm
right?
joking.
Community. Routing is an issue because we have JSON, right? So you cannot be guaranteed that the model field is at the very beginning of the document. It could be at the very end. It's not like structured like that. So unfortunately, you need to scan through the whole thing. But all these things, they have header overrides, model overrides, right, like that. So that's already built into AI Gateway. So if you can control your deployment topology, you can already do model override and then make some things more efficient. That's what the gateway is actually bringing you, is that flexibility in the router layer. So yeah, anyway.
Thank you.
Yeah, I just want to sort of say a little bit that, yeah, that's we picked that architecture on purpose with the external processing and modularization, so we can iterate fast. And we also want to make Envoy flexible enough that we can actually surface this higher level I mean, it's application protocols, whatever is encapsulated into HTTP, into the XProc consumer. So you can write an XProc server that consumes JSON RPC or MCP specifically, and sort of don't need to deframe these protocols from HTTP. This will allow us to sort of separate even more the common parts into Envoy and the business logic into these easily extensible pieces.
Thank you. Last question, I guess.
I believe that's the last question. What is the overhead compared with normal load balancer? And does the overhead matter in this case if the request is going to take 10 seconds or so?
So I think I'm not sure. I'm not following your question. Sorry.
I mean, like using the this new AI way of load balancing, you have overhead, right? Because you gotta parse. Sorry, you gotta parse the record body instead of headers, etc. So there is overhead on that. And what is the overhead you guys measured? And does the overhead even matter if the request is gonna take like 10, 50 seconds instead of loading a list of resources or whatever?
So we haven't done like comprehensive like measurement of what's the overhead of Envoy AI Gateway have. But thing is that, as I think I mentioned, that like few seconds of latency is really normal. So in that case, few milliseconds of like parsing body, I think it doesn't matter. I think that was like initial expectation we had, but we need to do additional research on that aspect. So the thing is, when we are releasing 1.0 next year, I think we have to do some optimization work in that aspect, like trying to explore maybe stream JSON parsing to extract body and so on. Yeah, that's the.
I see.
Yeah.
Well, thank you.
Yeah. Thank you.